Good day, class. In this video, I am going to show you the solution to quiz number 2 for our subject ESI 131 Engineering Economy. Now, let's start with problem number 1. So, in this problem, we have an industrial engineer uh, who needs to select these two alternative methods in accomplishing a production job. So, for the first method, that is method A, it utilizes three men, in which each of these three men has a rate of 40 pesos per hour. And then each of these three men can produce 12 units in 1 hour, in which there are 4 units that is being rejected during the production process. Now, the next alternative method is method B. So, in this method, it utilizes 2 men, in which the rate per person is 45 pesos per hour, and each of these 2 men can produce 10 units in 1 hour, of which there are 2 units that is being rejected during the production process. So since we have some rejected units, so the cost of this direct material loss is 30 pesos. So if a certain total number of units is to be produced, the requirement for this problem is we are going to select which method is not economical. So since it is not economical, that is, we're going to select the method that produces more cost. Okay, now this problem is an example of the selection of alternatives or selection of solution for the present day economy, in which we are only concerned with the initial cost of the alternatives. We did not consider the effects of the interest rate of the money. Now, in order for us to determine which method is not economical, so we are going to evaluate these two methods, and we're going to compute the total cost for each method. Now, let's start our solution by evaluating the cost of method A. So for method A, we have two uh, different types of cost. We have the labor cost and the cost of direct material loss. Now, for the labor cost, this is based on the number of successful outputs. We all know that the production rate of the workers has some rejected units. So there are only effective number of units, or we call this number of successful outputs. Now, to compute the labor cost, simply multiply the number of workers involved, so that is 3 men for method A, multiplied by the rate per person, that is 40 per hour, and multiply their production speed, that is the successful outputs that they can produce in 1 hour is only 8 units. So the labor cost is 15 pesos per unit. Next is for the cost of the direct material loss. So this is based on the number of projected outputs. Now, in a certain operation, so the rate of the direct material loss is 30 pesos per hour, and the number of rejected outputs in 1 hour is 4 units. So we have the total uh, direct material loss of 7.5 pesos per unit. Next, we're going to add these two costs. Therefore, the total cost for this method is 22.5 per unit. Next, we're going to evaluate the second method, that is method B. Again, let's start with the labor costs. So this is based on the number of successful outputs. So for method B, it only utilizes 2 men, and then same with method A, the rate is 45 per hour, and it can only produce successful outputs of 8 units in 1 hour. So we have a labor cost of 11.25 per unit. For the cost of direct material loss, so this is based on the number of rejected outputs. Same with method A, the rate is 30 per hour, And from the problem, the number of rejected units for method B is 2 units in 1 hour. So we have 15 pesos per unit for our direct material loss. Therefore, the total cost of method B is equal to 26.25 pesos per unit. Now, once we are done with the evaluation of these two methods, the next step is to compare their total cost. So again, for method A, that's 22.25 per unit. For method B, 26.25 per unit. So this is very obvious. By comparing their total cost, we can say that method B is more costly than method A, and it is therefore not economical. Okay, let's proceed to problem number 2. So in this problem, um, the goal here is to select the best material for the set of tools on our lathe machine. So we have two alternatives. The first one is by using high carbon steel, and the second one is by using alloy steel. Now, if we are going to use the high carbon steel, it can output 70 pieces in 1 hour. And then for this problem, we have um, two situations here, that is the grinding time and the time in changing the tools. So for high carbon steel, the grinding time is 5 hours, and then the time in changing the tools is 2 hours. Now for alloy steel, it can output 80 pieces in 1 hour, and then the grinding time is 7 hours, and the time in changing the tool is 2 hours. So the wage of the lathe operator is 50 per hour. This is based on the actual working hours, or this is based on the uh, tool grinding time. Next is the rate of the tool changer is 60 per hour. Then we also have an overhead cost. So this is cost other than the lathe operator, other than the wage of the lathe operator and the wage of the tool changer. So the rate here is 45 pesos per hour. This is based on the accumulated time for the grinding and the changing of tool. Then the cost of the unsharpened high carbon steel is 500 pesos, and this one can be used 10 times, or this can be ground 10 times. Next, for the alloy steel, the cost for the unsharpened alloy steel is 850, and it can be used 5 times. So the question here is, we're going to select which type of steel should be used for our set of tools on the lathe machine. So we are going to evaluate the cost of these two alternatives, and if ever which of them produces much lower cost, then we're going to select that material. Okay, so we're going to evaluate each of these materials. Now let's start with the high carbon steel. From the problem, you will be able to identify four different types of cost. First is the cost of the unsharpened high carbon steel. So that is 500 pesos, and it can be used 10 times. So per cycle is the cost is 50 pesos. Next is for the wage of the lathe operator. So the rate is 50 pesos per hour, and then the grinding time, since the wage of the lathe operator is based on the grinding time, so we have 50 times 5 hours. We have a total of 250 pesos as the wage of the lathe operator. For the wage of the tool changer, so the rate is 60 pesos per hour multiplied by the time in changing the tools. So we have 2 hours. The total is 120 pesos. Now for the overhead cost, the rate is 45 pesos per hour and multiplied by the accumulated uh, time for grinding and for changing the tools, and that is 7 hours. So we have an overhead cost of 315 pesos. Next is we're going to sum up all this cost. So we have the total cost of 735 pesos, and this is per cycle or per operation. Next is we are going to get the total cost per piece, since we all know that from the problem, if we're going to use the high carbon steel, we can produce an output from our lathe machine, and the rate is 70 pieces for high carbon steel. So we're going to take into account the output of this material. So let's proceed uh, with that part. So we have total cost per unit. So we have 735 pesos per cycle, and in one cycle or one operation, it will take 7 hours. So that is the sum of the grinding time and the time in changing the tools. So in 1 hour, based from the problem, so this material can produce 70 pieces. So we have a total cost per unit of 1.5 pesos or per piece. Next, let's proceed to the alloy steel. So again, we have these four different types of cost. So for alloy steel, the cost of the unsharpened is 850 pesos, and it can be used 5 times. So in one cycle, we have a cost of 170 pesos. For the lathe operator, same with the high carbon steel, the rate is 50 pesos per hour. But for the alloy steel, it will take 7 hours for the grinding operation. So we have a cost of 350 pesos. For the tool changer, the rate is the same with high carbon steel. The only difference is the time in changing the tools, that is 2 hours. So we have an accumulated cost of 120 pesos for the wage of the tool changer. Next is the overhead cost. So same with high carbon steel, the rate is 45 pesos per hour, but they only differ with the time for one operation or for one cycle, because it will take 9 hours for the alloy steel. So we have an accumulated overhead cost of 405 pesos. Next is we're going to sum up these. We're going to sum up all this cost. So we have a total cost of 1,045 pesos, and this is per cycle or per operation. Next is to get the total cost per unit. So we all know that if we're going to use the alloy steel, we can produce around 80 pieces in 1 hour. So you have 1,045 per operation, and for alloy steel, a single operation can last up to 9 hours. And then if we're going to use this material, it can produce 80 pieces in 1 hour. So we have a total cost per unit of 1.45 pesos. So next is we're going to compare their total cost per unit. So for high carbon steel, that is 1.5 pesos. For alloy steel, that's 1.45 pesos. So by comparing the two, we can say that the alloy steel is cheaper than the high carbon steel by an amount of 0.05 pesos. So our alloy steel is therefore economical. Next, let's proceed to problem number 3. In this problem, we have an engineer bidding on the asphalting of an 8-kilometer stretch of road is confronted with the problem of choosing between two possible sites on which to set up the asphalt mixing machine. So this engineer needs to select two possible sites. We have site A and site B. So for site A, its distance uh, from the project is 3.5 kilometers. And then the monthly rental is 4,500 pesos. And the installation and dismantling cost is 18,000 pesos. Now, this site also requires um, 3 flagmen. Okay, in this sentence, it requires 3 flagmen, in which the rate per flagman is 25 pesos per day. Okay, now let's proceed to site B. So site B, its distance from the project is 3.5 kilometers, which is closer compared to site A. And then the rental is 650 pesos. Then the installation and dismantling cost of the equipment is 8,200 pesos. Then the asphalt mix for both sides is to be hauled by a subcontractor, in which the rate is 0.52 pesos per cubic meter of asphalt mix and per kilometer of hole. Okay, so this per kilometer of hole is the distance of the site from the project. Next, the job can be completed in 30 weeks, or that's around 7 months, and then they are going to work 6 days in a week. So the project requires 17,670 cubic meters of asphalt mix per kilometer of road. So this is a function of um, the kilometers of road that needs to be covered with asphalt. So the question here is, we're going to select which side has the lowest, or has a lower cost compared to the other. And the second requirement is, how much lower would this site be compared to the other site. Now, same with the previous two problems, we're going to evaluate each of this site. Now let's start with site A. Now from the problem, uh, you will identify four different types of cost. So we have the cost of the monthly rental. Next is the cost of the dismantling and installing the equipment. Next is the hauling cost, or we also call this one as the transportational cost, because the engineer needs to transport the asphalt mix from the site towards the location of his project. Then lastly, we have the cost of the flagment. So this cost is only for site A, because for site B, it does not require any flagman to do the job. So let's start with the monthly rental of site A. So from the problem, that is 4,500 per month. And we all know that the project will take 7 months. So the total cost of monthly rental is 31,500. Next is the cost of dismantling and installing the equipment. So this is a fixed cost, and that is equal to 18,000 pesos. Next is the hauling cost. So from the problem, the hauling cost is a function of the number of cubic meters required for the project, and the number of kilometers, no, for the asphalt, for the asphalting, and also the number of kilometers, or the distance from this site towards the engineer's project. Okay, so the rate of the hauling cost by a subcontractor is 0.52 pesos per cubic meter and per kilometers of haul. So we have, for this project, it requires 17,670 cubic meter. Then per kilometers of road, we all know that in this project, we're going to cover an 8-kilometer stretch of road. So this unit will be cancelled out. And then the 3.5 kilometer of hole, this is for site B, its distance from the project. So this unit will be cancelled out right here, and the cubic meter will be cancelled out. So what's left is the peso unit. So for the hauling cost for site A, that is 257,275.2. And let's proceed to the cost of flagmen. So for site A, it requires 3 flagmen. The rate is 25 pesos per day. And for this project, this flagman will work 6 days in a week, and the project will take up to 30 weeks. So the cost of the flagman is 13,500 pesos. Then next step is to uh, add all this cost. So we have a total cost for site A, that is 320,275. pesos. Next is we're going to evaluate the second site, which is site B. Now for site B, it does not require any flagman to do the job. So we only have three different costs. So for the monthly rental for site B, the rate is 650 per month. And then the project will already know this one, it will take up to 7 months. So the cost of the monthly rental is 4,550 pesos. Now for the dismantling and installing the equipment, it is cheaper compared to site A because for site B, we only need 8,200 pesos. And next, the last cost is the hauling cost. So the same with the site A, the rate of the subcontractor is 0.52 pesos per cubic meter of asphalt and per kilometer of hole. So again, this project requires 17,670 cubic meter per kilometer of road, and this project needs to cover an asphalt of 8 kilometers of road. And then the distance of this site from the project is 3.25 kilometers. So the all units are cancelled out. What's left is only the peso sign. So the hauling cost for site B is 238,898.4. So the last step is to add up all these costs. So we have a total cost for site B that is 251,648.4. So the last step is to compare their total costs. So for site A, that is 320,275.2, and for site B, that is 251,648.4. So by comparing the two, it is obvious that site B is cheaper than site A. So site B is therefore more economical compared to site A. So the next requirement is by how much cheaper is site B compared to site A. So simply subtract the cost of site A and the cost of site B, and that is 68,626.8. Okay, so thank you for watching and God bless.